All right, I'm going to do a video on this first discussion item here for week 4, part 1 discussion. So if I go to the discussion item here, and then let me go back here and reset this. So if you go to the modules for this week, you go to the modules link, and then down here is what you should see is week 4, part 1 discussion, the quadratic investigation, and then the Desmos calculator comes up, and here are some points. And how many different quadratics can you find that pass through 3 given points that are distinct, that are all different? So here is one parabola that I can find, and I can only, so if I move these around, in other words, so I say I put that one there, and then this one down here, and this over here, then there's a distinct parabola there. So, or if I move these down like this, then the coefficient of x squared would be negative. So if I drag these points downward here, such that the parabola opens downward, then the coefficient of x squared would be negative. If I put them back up here, then they're positive. And so the coefficient of x squared here is positive. Can you find any sets of 3 given points that do not have a quadratic that passes through them? So if I could, if I do this here, so if I can drag these points, so, and then if I make them collinear, then it would be a line. So that wouldn't be a quadratic. That's actually this equation here is 4x plus 9, or plus negative 9, or 4x minus 9. There's a plus right there. You might not be able to see that, but it's just the equation of this line is 4x minus 9. So if I put the 3 points collinear or in a line, then there wouldn't be a quadratic through those 3 points. And then it says to use the applet to determine the second degree equation that passes through these 3 points. So we're going to drag A over to -1, -6, and B to 0, 1, and then C to 2, 3. And there is my quadratic. It's a parabola that faces downward. My quadratic would be -2x squared plus 5x plus 1. So it says we know that 2 distinct points determine a unique line. We'll write a conjecture about points and quadratics. And can you generalize to higher degree polynomials? So if I have 3 points, so in order to write a polynomial of a higher degree, so 2 points would be degree 1, that's a line. 3 points would be degree 2, which would be quadratic. So in other words, I'd need 4 points to make a cubic, 5 points to make a quartic, and so on. So the number of points that we need would be 1 more than the degree of the polynomial that we're going to write. So I'll show you how to get this equation here using matrices. So further along in the lesson, they're also going to show you that, or they showed you that before, of how to find this quadratic with these 3 points. So let me go to the Promethean software and show you how to do that on given those 3 points, how to find the equation through those 3 points. So going back here, the 3 points are -1, -6, 0, 1. So A, let's see if I can write on here. Point A is -1, -6. Point B, looking at point B, is 0, 1. And then point C is 2, 3. And we know the general form of a quadratic is y equals ax squared plus bx plus c. So we're going to plug each one of these points in to this equation, and we're going to have 3 equations and 3 unknowns. The unknowns are going to be a, b, and c. We're going to find out what these 3 numbers are by using matrix equations. So the first point, a is -1, -6. So that means that -6 is equal to a times -1 squared plus b times -1 plus c. And for the point b, which is 0, 1, you have 1 is equal to a times 0 squared, and then plus b times 0 plus c. Well, that's just going to give you that c is equal to 1, and then we could probably solve it easily. But just like in the video, we're going to use matrices equations, even though we know what c is right away here, because this would be 0 plus 0 plus c is equal to 1, so c is equal to 1. And then the third point, 2, 3. So now you have 3 is equal to a times 2 squared plus b times 2, and then plus c. So the 3 equations we would have would be -6 is equal to a minus b plus c, and 1 is equal to 0 plus c, so just put plus c here. And then 3 is equal to 4a plus 2b plus c. So if I make this a matrix equation, then I'm just going to use the coefficients of all these letters here. So 1, -1, 1 would be the first row. The second row I have 0 A's and 0 B's and then 1 C. In the third row I have 4 A's, 2 B, and C. So 4, 2, 1. And then this matrix is going to be A, B, C. And then that's going to equal -6, 1, and 3. So if I call this matrix A and this matrix X and this matrix B, then matrix X is equal to A inverse times B. So I'm going to use my calculator now and do the inverse of this matrix times this one. and I'll get what A, B, and C are. So going to my matrix calculator. So I'll just type in Desmos matrix calculator right here, and I'll come up with a Desmos matrix calculator. Right here. So matrix A is a 3 by 3, so I'm going to do new matrix 3 by 3, add it, and there's my matrix A. I'm going to fill that in with 1, -1, 1. So 1, -1, and 1. And then second row, 0, 0, 1. So 0, 0, 1. And then row 3. So row 3 is 4, 2, 1. And then hit enter, and then in a new matrix, B is a 3 by 1, so 3 by 1, and then -6, 1, and 3. -6, whoops, -6, 1, and 3. And then if I just do A inverse times B, and I get -2, 5, and 1. So -2, 5, and 1. So matrix X is -2, 5, and 1. So in the original right here, it's going to be y equals -2x squared plus 5x plus 1. And then going back to my slide where I actually plotted these points on the Desmos screen there, I should match this equation right here. So let's go back and look at that. So here's our equation here. Y equal -2x squared plus 5x plus 1. That matches this one here. Y equal -2x squared plus 5x plus 1. So that's the video on the discussion. Should help you realize what the answers are to the discussion items there. So if you haven't answered the question yet, you should look at this video first and then answer the questions and see how to make a polynomial function using this format. So we're looking for a quadratic here. The general form is like this. So if we're looking for a cubic function, it would be similar, but it would be like this. So we did need 4 points if you wanted to do cubic function, but your general form would be ax cubed plus bx squared plus cx plus d, and then you would plug your 4 points into here, what your x and y values into here, and then you would find a cubic. So you would need one more point for the graph than the degree. So this degree is 3. I would need 4 points to find the equation. So you'll see that in one of the next videos if we need to do that. So we need to find a function a cubic or a quartic function, then I'll show you how to do that in the check for understanding. So I'll do one of the problems there to help you figure that out. All right, so let me stop this video and post it under the week 4 module.